Hey guys, welcome to the session by K21Academy. In this session, we are going to learn about Docker Container Lifecycle and Docker basic commands. Now let us take a quick glance at the agenda. Firstly, we will be going through Docker commands. Post that, we will try to understand the container lifecycle. And then finally, we will be going through Docker container commands with detailed explanation. So we have taken a clip from one of our certification training program on Docker and Certified Kubernetes Administrator, which is CKA. In this clip, our expert will talk about Docker Container Lifecycle and Docker basic commands.
Hello and welcome to this video. In this video, we would learn how to work with containers. So we would learn some of the basic commands which would help us to work with containers. First command is the Docker version, which we saw in a few videos back. We saw when we installed Docker, how can you check the version of software, which version of Docker got installed. Docker info is another command which helps us get the complete detail about the Docker daemon which has been up and running, the complete software. And there is a path wherein 𝗏 Docker, where all the objects created by Docker would be listed. Let it be the images, let it be the containers, the volumes, anything which Docker manages would be listed in this path. And in case you want to do some configuration setting for Docker daemon, then /etc docker is the path for that. So let me take you to my terminal and let me execute the Docker info command and show you what details can we see in this. So Docker info shows us what is the software package number, like 1904. It shows us the storage driver name. It shows the file system which is being used. What is the default logging mechanism? All the containers would be logging as JSON. What is the C group driver which is being used? The volume, what sort of volumes can we mount inside the container? And if you see here, the runtime, runc is mentioned over here. And we are not using Docker in the swarm mode, so this shows us inactive. And then you have the kernel version, the operating system version. So this is the complete detail about the virtual machine on which this Docker daemon is up and running, right? And if you see, we would go ahead and connect to the hub.docker.com software of the server, from wherein we will install packages or images for any containers. So this is the one where it lists the registry with which it would be connecting to download the images. So this was the command for Docker info, and you will have to do a sudo and then go to the 𝗏 Docker path. So I'll just quickly show you what does the path contain. Okay, I would have to just do sudo su first. Sorry, my bad. And then you can do a cd on 𝗏 docker. And yes. And if you see here, it lists all the containers, the image, the network, the drivers, the plugins, the runtime, the volumes, everything gets listed over here. And same way, /etc docker is the path for the configuration. At present, that should be empty. By default, no daemon.json file is there. It's just the key.json file, and daemon file settings are not there. So this daemon has come up with default settings. And in case we want to configure any specific parameter for this daemon, we can go ahead and create a daemon.json file and feed in our parameters. We would look into daemon.json when we do the DNS exercise. So I'm going back to the home directory, and let's go further and understand how does the container lifecycle work. Okay, so you can create a container with Docker container create command, and once we execute that command, the container goes to created state. It's created, but it's not up and running. It's existing, but it isn't stopped state. Okay, so we can go ahead and do a Docker container start, and we can start the container. As soon as you start the container, what does that mean by starting, spinning, or running the container? That means the processes inside the container starts the execution. So once you execute the docker start command, your container is up and running. Instead of going in two-step process, first create and then start, rather than that, you can execute a single command called as docker run that would create and even start the container. And as soon as you execute the docker run command, container goes to running state. If I want to stop my running container, it is like a graceful stop I want to do, then I can execute the docker stop command with the container ID or container name, and docker container moves into the stop state. You can go ahead and remove the container completely from this Docker host's memory by doing a docker rm, and docker rm would delete the container. So stopping the container means the container is not running but existing in that system. You can find that container in an exited state, but once you do a docker rm, it gets deleted and it's no more there in the system. Okay. But if I have stopped the container and I want to come back to the running state, then start command can be executed. So docker start and give the container ID. It will bring back the container process to the running state. You can even pause the process which are running inside the container by executing docker pause command. And difference between stop and pause is when you are saying stop, the container processes are completely killed and container moves to exit state. When you say pause, processes are still there, but they are not utilizing or they are not executing any of the processes at that point in time. They are just on hold. So once you pause that, the container moves to pause state. And in case you want to unpause that back, you can type in docker unpause command. So this way you can go ahead back to running state. I can even go to deleted state from created itself. I created a container, but I didn't want to run it. Then I can go ahead and delete the container using docker rm command as well. So these are few of the states in which you can run your containers. It would be executing in one of the either states. Let's see some of the basic commands with which you can create a container. So docker run creates and executes the container both. You can create a container in an interactive fashion. -I and T means -I is for interactive and T is for the TTY. As soon as you do a docker run -IT and specify the image. So here Ubuntu is the name of the image and bash is the process with which you are starting the container. So it will create Ubuntu container and start a bash process inside it. And because we have mentioned -IT, it will interactively take me inside the container's prompt. So as soon as you execute this command, you would land into the terminal inside the container. Let me do that for you and show it. So docker, I'll just clear the screen. So docker run -IT, I'm giving Ubuntu image and I'm saying bash process. And if you see, we are not dealing with images. We would do that in the next section. So just for now, skip what is the image which is coming. Just understand it is picking up the Ubuntu operating system template and then spinning up this container. And if you see, you are inside the container's terminal. And root is the user with which you have started the container. And this is the container ID. Actually, this ID is pretty huge, but here it just lists the starting 12 digits of the container ID. Okay, so we are inside the container's terminal and you can see by typing in PS, bash is the primary process which we started during the container creation. That is the primary process which is running inside this container. In case you want to exit from this container because we have gone inside the container in an interactive fashion and you want to exit from the container and you don't want to stop it, you can press Ctrl+P and Ctrl+Q in sequence and come back to your virtual machine's terminal. So if you press Control P, Control Q in sequence, that time you would be exiting from the container's primary process and coming back to your virtual machine's terminal. How to list if the container is up and running? You can do Docker PS, and here you can see this is the container ID, the image with which your container has pinned up, the command which you executed, when was it created, what is its state, and the name of the container. Because we didn't specify -- name during the creation of container, it has automatically given itself a name. The container is named by the Docker daemon. So this way you can create container in an interactive fashion. Whenever you are saying interactive, you interactively land inside the container's terminal. The other way of creating is in the detached mode. That means as a background process. And in that case, you would not be landing inside the Docker's terminal, the container's terminal. Rather, container would get created, but you are still on the virtual machine's prompt. So the option would be Docker run, -d stands for the detached and the TTY, and Ubuntu bash is the image and the process with which you are starting. So let's execute that as well. Docker run -dt, and I'm giving Ubuntu, and I'm giving bash as the process to start. Container has started, and this is the complete container ID. And I can list the running containers with Docker PS command, and you see now I have 2 containers up and running. Here it just lists the starting digits, but actually the container ID is such a huge one to get that uniqueness. And here also it has named the container by itself, and both looks very alike, but here we didn't land into the terminal of the container because we started it as a background process. Here we had started it as a foreground process. We logged in inside the container's terminal as soon as the container was created. That's the difference between these 2 commands. We listed all the containers which were running with Docker PS command. In case few containers are in stopped state or paused state, you can do Docker PS -a and list all of the containers as well which are present in this Docker host. Suppose I go ahead and I do a Docker stop on one of the containers. Let me stop a container. Command to stop would be Docker stop with container ID. And this time if I do Docker PS, it would just list one container because PS lists all running container. If you give -a, that means --all, list all containers, you can find your first container which is there, it shows up and running, and the container which we have stopped, that is showing as exited. So this particular container is now exited. The processes are not running, but the container is still there in the memory. You can quickly go to cd var lib docker, and you can see these containers are listed. So here you should have containers. I'll just go inside that and do an ls. You have those 2 specific containers. You can see that even the IDs are matching. Here ff7e and 6605 is the container details. So whichever containers you're creating, everything gets listed over here, and these are all container related files which we are retaining over here at this point. Same way, if you have the images created, because we downloaded the Docker image, we should have one of the images over here as well. But images are maintained in layers, so we would have the layer database having lot of layers which was related to the image of Ubuntu. So we would be seeing these images in the next section. For now, let's work with containers, and hopefully we have learned how to create a container now. So when we want to list the processes which are running inside the container, because we understood that when a container is created, it is actually going on the Linux kernel level and spinning up a process. So somewhere we should be able to visualize or see the process which is running, right? So when we do Docker PS and we can even go and grep for all the processes which are running connected to the Docker daemon. So Docker ps command would show the running containers, and if I execute ps-fxa, this is for listing the processes which are running, and I'm grepping for all Docker related processes. You would find multiple sections populated here like this. So let me quickly show you that particular command, ps-fxa, and I'm grepping for Docker. I'd say grep Docker, and I want to list at least 3 statements for each of the sections. Then I have written -a3. If you see, this is one section and this is the other Docker daemon which is actually running. So this is the section for another one container which is up and running. If you see, we have just one container up and running. I'll do Docker ps. I just have one container. Let me start the other container which had exited. So what I would do, I would go ahead and do Docker start with the container ID and verify if the container is up and running. Yes, it is up and running. Now let me dump this command and show you that it would have multiple sections like this. We had understood that each time the container gets created, there is a container shim process which is running and the bash process which is running. In case bash, whatever primary process you started inside the container, that should be up and running, right? So here, if you see, bash and this shim is one section from here to here. This is the shim's process ID, and this is bash process ID which is running inside the container, and this is the second container's shim ID, and this is the second container's bash process ID, and this is the process ID for actual Docker daemon which is up and running. I can go ahead and kill my containers by just killing the bash process as well. So we will discuss about the primary and the secondary processes going ahead. Let's list few of more of the commands which we can work with containers. If I want to remove the container completely from Docker's memory, then I will do Docker rm with the container ID. And if my container is already up and running, but I'm not connected to it, like how we had started that container in detached mode, it is running in detached mode and you just want to connect to that container, then you can do a Docker attach with the container ID and get into the container. But you can only attach to the process which provides you a terminal, like the bash type of process or a shell type of process. Another way to connect to the container is to do a Docker exec. Exec stands for execute. You can execute a command by connecting to that container using Docker exec command. There is a difference between how we attach using Docker attach statement to a running container or how we connect to a running container with Docker exec. We would see that in our demo. So let me clean the screen and let me execute this Docker ps command. These two containers are up and running, but I'm not connected to that container. I'm not inside the container's terminal at this point in time, right? So what we would do, if I want to connect to that container with Docker attach command, I would execute Docker attach and I'll give the container ID. So here, this is the container ID. And if you see, as soon as I did Docker attach, I have gone inside the container's terminal. I can come out from that by doing just Control C and I'll just do a Docker ps over here. I would connect to the container with Docker exec command. So let me do a Docker exec and show you the difference. If I do Docker exec -it and if I give the container ID, let me give the other container ID. I can connect to the same container as well, but I'm just connecting to a different container. And here, if you do ps, you would see this bash process has a different process ID. This bash process is not the same bash process. I'm opening a new bash terminal in the same running container. So what happens? I was running a container with one process inside. So I started a container over here on the Docker host and bash was the process which was running. Let me reduce the size of the brush, and this is the primary process which is running, okay, inside the container. So this process is up and running, then the container is up. If the primary process is killed, the container gets killed. So if you do a docker run command and you enter inside the container with -it, say Ubuntu with bash, and this becomes the primary process. So what we did, we pressed Control P and Control Q to come out of this terminal, the root terminal of the container ID. We did this. In case we would have typed exit, it would have killed this bash terminal, and because it was the primary process, this container would have moved to exited state, and that is the reason we did Control P plus Control Q instead of typing exit. Same way, when you do docker attach and you give this container ID now, the same container ID, you connect to already running process. You are not creating any new process. You are just connecting to the already running process, and you're connecting here to the same primary process, the bash process. And you go to the bash prompt, and this is the same bash process which you have started, you have connected to. So in case you type exit, because this is the primary process to which you have connected, again the container would die. So to be on the safer side, what we would do, in case I am running a primary process, still then if I want to do any debugging and all, instead of connecting to the primary process, you would always execute using a secondary process. I will give the container ID and I'll give a bash. This time this bash and the primary bash is different. I'm saying execute interactively in this container the bash process. So what would happen? You will again log in and you would land inside the bash process. You are into the bash terminal, but if you do PS, you would find this bash process ID is not 1. It is having some other number like 8 or 9. But this bash process ID is always 1. Always the primary process has process ID 1. And secondary processes have some other process ID number. Okay, so this process is secondary process. So if you type in exit on this terminal at this point in time, you would exit and you will come back to the virtual machines terminal and your container would be up and running as well. So what we learned from this, that in case you want to start a process, which is the actual intention of starting the container, you start that container with the primary process of that. That should be the primary process. Like for example, I want to create a web server container, then web server's daemon, whatever is there, let it be Nginx or HTTP or any Apache web server, that should run as the primary process inside the container, and you can run any other secondary process like bash and connect to the container and execute commands in that. Hopefully this is clear.
So we have put down everything about the certification, including the basic concepts that one should know everything like microservices and Docker, networking, storage and app stack in Docker, Kubernetes architecture and installation, security, troubleshooting and high availability, networking, deploying, application stack and advanced networking. In this 12-week roadmap, we take you from basics to advanced level along with the tips and resources for clearing the certification exam. We also have a separate team working for CV preparation and on-job support. So if you want to become Docker and certified Kubernetes administrator and want to learn right from basics to expert level, then we have a comprehensive step-by-step training for you that includes hands-on labs, including exam preparation, and the most important part, 1 year on-job support. If you are interested in this program, then I would highly recommend you to attend our free class which covers most of the topics like why learn Docker and Kubernetes, and under Docker, you will be learning what is container in Docker, Docker architecture. And under Kubernetes, you will be learning what is Kubernetes, why to use it, Kubernetes architecture and pods, highly available and scalable applications, and many other topics. So if you are interested in attending this free class, you can visit k21academy.com/kubernetes02. You can also find the link in the description.